Hey everybody, welcome back. All right, this is part 2 of the 8.6 notes. All right, so now let's take a look at example 3, where we want to find the area between the curves of g of y equals 4 and h of y equals y squared. So let's go ahead and graph this real quick. Remember, this is the same thing as saying x equals 4, and this is the same thing as saying x is equal to y squared. So let's just go ahead and graph that to get an idea of what it looks like. All right, so if we're going to graph x equals 4, that's pretty simple. It's just a vertical line 4 units to the right. And if we're going to graph x equals y squared, that's going to be a sideways parabola, 0, 0. You're going to go right 1, up 1, and down 1. Right 4 is going to go up 2 and down 2. And then you'd have to go right 9 before you went up 3 and down 3. All right. So what we are trying to calculate is the area bounded between those functions, which is here. So what I would recommend you do, guys, is pause the video and make a decision on whether you want to find it in terms of x or y, or possibly just try to do both. Okay, but pause the video and try it on your own. All right, now for me, guys, as I take a look at this, I see that the blue line is always to the right of the red sideways parabola. So I'm going to go ahead and do this in terms of y. I'm not going to bother doing anything in terms of x. So in terms of y, all right, and just a reminder, when you do it in terms of y, you are using those horizontal slices. So you'll hear that mentioned, which is basically taking that area and accumulating it. So when we set it up, everything has to be in terms of y. So our integral is going to go from the lowest point to the highest point, which is -2 to 2. Our function that's to the right, okay, because again, it's right minus left, is that 4 minus y squared. Okay, and we're going to integrate that in terms of y. Again, we don't need a calculator for this, so let's just go ahead and do the integration. Integral of 4 is going to be 4y minus 1/3 y cubed, and we're evaluating that from -2 to 2. Plug it in, we've got 4 times 2 minus 1/3 of 2 cubed. And then we're going to subtract 4 times -2 minus 1/3 of -2 cubed. From here, it's just a matter of simplifying everything down. So we got 8 minus, that's going to become 8/3. Now, it's important to remember that all of that is being subtracted. So you're going to end up with -8. And then let's see, we got -2 cubed is -8. -8 times -1/3 is going to become +8/3. But then because we're subtracting, I'm going to go ahead and just change those signs. All right, 8 plus 8 is 16. -8/3 plus -8/3 is -16/3. So we would need a common denominator, which would give us 48/3 minus 16/3, which is 32/3. All right. And you could obviously use the calculator to check your answer and verify that it is correct. All right. Let's go ahead and move on to example 4. And you'll kind of notice this is an FRQ from 2013. It was FRQ number 5, which means it is a non-calculator problem. So that's important for you to know. When can you use a calculator, when can you not? So let's see what it says. Let f of x equal 2x squared minus 6x plus 4, and g of x equal 4 cosine of 1/4 pi x. Let R be the region bounded by the graphs of f and g as shown in the figure. We want to find the area of R. All right, so again, this is the area between two curves. Pause the video, try it on your own, and see what you come up with. All right, so now, as I'm looking at this, the first thing we got to do is decide which one's f and which one's g. So f of x is a quadratic, it's positive. So it's got to be a parabola opening up. So that's going to be this bottom curve. All right. G of x is for cosine. So cosine starts with a maximum, which means that this top function is going to be g. All right, now we do want to make that decision. Do we want to be in terms of x or in terms of y? Guys, when you look at these equations, the equations are given in terms of x. It's going to be pretty difficult to rewrite them in terms of y. Plus, when you look at the graph, you've got g of x always on top of f of x. So this just makes sense to do it in terms of x. All right, so we're going to go ahead and set up the integral. So in terms of x, we're going to start at 0 and end here at 2. All right, and it's going to be top function g of x minus bottom function f of x with respect to x. Now, since we can't use a calculator, we're going to need to go ahead and plug in those functions. So we've got 4 cosine of 1/4 pi x minus, and that's going to go in parentheses, 2x squared minus 6x plus 4. And all of that is being integrated with respect to x, at least for now. Now, as I look at this, you can leave it as one integral or you can split it up. And because of this, I'm going to need u substitution, so I'm going to go ahead and split it up. So the first thing I'm going to do is I'm going to go ahead and let u equal that 1/4 pi x, which means that du is going to be pi over 4 dx, which means that 4 over pi du is dx. All right, so now what I'm going to do is I'm going to end up splitting this up, and I'm going to rewrite this in terms of u. So what that's going to look like is, just kind of bear with me for a second. You've got this 4 over pi that's here. I'm going to take that 4 out as well, so times 4. And then it's going to be times the integral cosine of u. We're going to change our limits of integration in terms of u. So if u is 0, it stays 0. But if u is 2, or if x is 2, excuse me, then 2/4 pi is pi over 2. All right, and that's integrated with respect to u. But then this is going to stay in terms of x, so I'm going to go ahead and just rewrite it. Guys, and just understand there are alternative ways to do this in terms of leaving it as one integral. I just find this a little bit easier for myself. All right, so as I look at this, this becomes 16 over pi. The integral of cosine is sine, so that's going to be sine of u evaluated from 0 to pi over 2. And then minus, all right, over here, that's going to become x cubed, so it's 2/3. Minus, this becomes x squared. 6 divided by 2 is 3, plus 4x, and we're evaluating that one from 0 to 2. All right, so keep that in mind. We've got 16 over pi. This becomes sine of pi over 2 minus sine of 0. And then you're subtracting all of this. So this is 2/3, 2 cubed minus 3 times 2 squared plus 4 times 2. And then when I plug in 0, it's all going to just become 0. So I'm not going to worry about showing all of that. All right, at that point, let's keep simplifying this down, see what we come up with. We've got 16 over pi. Sine of pi over 2 is 1. Sine of 0 is 0. And then minus, all right, 2 cubed is 8 times 2. That's going to be 16/3. 2 squared is 4 times -3. That's -12. Plus 8, and then minus 0. This becomes 16 over pi. What you would want to do here is get a common denominator. So I'm just going to go ahead, without having to rewrite all of this, this becomes 36/3. This becomes 24/3. So 16/3 minus 36/3 is -20/3. -20 plus 24 is +4/3. So it's going to be minus +4/3. And that's all we can do. And that's the answer. All right. So a little bit going on in there. You definitely got to be careful and kind of look at things. You can look, the solution is below, and this kind of gives you an idea of what the scoring breakdown looked like on the FRQ that year, where you got 1 point for the integrand. So that's essentially this or this step. And then you got 2 points for the antiderivative, which I'm assuming you're going to basically get 1 point for each correct antiderivative, and then 1 point for evaluating. And again, this is their work. They did things a little bit different because they left everything in terms of x. Okay, again, both ways are correct. All right, I believe we got one more example. We'll go ahead and fit it in this video. This is from 2014. This was FRQ number 2, part C. So this is just part of one FRQ. It says, let R be the region enclosed by the graph of f of x, which is x to the fourth minus 2.3x cubed plus 4, and the horizontal line y equals 4. As shown in the figure, the vertical line x equals k divides R into two regions with equal area. Write but do not solve an equation involving integral expressions whose solution gives the value of k. So to kind of get an idea of what's going on, now I would pause the video, try to come up with it on your own. All right, but there's some vertical line that's passing through here with the equation y equals k that's going to divide that region into two equal areas. All right, so you're going to have the area on the left, the area on the right. Now, the first thing that we're going to need to know is, what are these points of intersection? Okay, so where do those two functions intersect each other? And the easiest way to find that is just write the equations equal. So x to the fourth minus 2.3x cubed, 2.3x cubed plus 4, we need to know, when does that equal 4? Well, if we move the 4 over, we get x to the fourth minus 2.3x cubed equals 0, because the 4's cancel. And then if you look, this is actually a pretty easy equation to solve. We can factor out x cubed, and you're going to have x minus 2.3, which gives us solutions of 0 and 2.3. So this point has an x coordinate of 0. It's actually 0, 4. And this point has an x coordinate of 2.3, and it's 2.34. All right, so that's going to be important in writing our intervals. So we want the areas to be equal to each other at that line k. So I'm going to need an integral equal to an integral, basically, because that's how we're going to find that area. The first integral is going to go from 0 to this value k. So it's from 0 to k. And because we're integrating from left to right with vertical slices, everything's in terms of x. So we're going to do top minus bottom. So it's going to be 4 minus f of x with respect to x. And for the second part of the region, after k, you're going to integrate from k to 2.3, which is that other point of intersection. And again, it still stays 4 minus f of x in terms of top minus bottom. And because all we were doing was writing the integral expression and not solving, that is our answer. So hopefully you guys found that helpful. Make sure you check out the videos, and if you need help, talk to your teacher, and I will see you next time.